Domino puzzle. You might think, domino puzzle? Yes. Why domino puzzle? Because, you know, dominoes, everyone knows what dominoes are. I could tell this puzzle to my 8-year-old daughter and she would understand it perfectly. She might even be able to solve it without any problem. Okay? So it's very easy for me to convince you, or it's very, very easy for me to convey to you the domino puzzle. Okay? So what is the domino puzzle? Okay, so I'm going to give you 3 dominoes as an example. So I'm giving you an example of the puzzle. Okay, so I'm going to give you 3 dominoes, D1, D2, and D3. 3 example dominoes. Okay, so what does a domino look like? It has 2 parts. So each of these dominoes have 2 parts. Okay, and now typically you would put a number in each part. Okay, and that's what makes a conventional domino. But since we're computer scientists, we're going to put a binary string. Okay, so a binary string in each part. So in here you've got a 0. And here you've got 1, 0, 0. And treat this as a binary string. So here you have 0, 1 and 0, 0. And here you have 1, 1, 0 and 1, 1. Okay? So you have 3 dominoes. And let us suppose that you have an unlimited supply of such dominoes. Unlimited supply. Okay? Now, the goal is to place dominoes in a sequence. So let me give you an example of a domino sequence. So consider the sequence D3, D1, D3. Okay, and I could put more dominoes if I wanted. I could put less. Okay, because remember you have an unlimited sequence of dominoes, and dominoes can repeat. Okay, so let's see what these 3 dominoes, when I put them next to each other, look like. So D3 is 1, 1, 0, 1, 1. D1 is 0, 1, 0, 0, and D3 again is 1, 1, 0, 1, 1. Okay, nice. Okay, now what I'm going to say is that when you put these 3 dominoes next to each other, you kind of concatenate them into one big domino. So this becomes a humongous domino, okay, where we concatenate the strings. Okay. So it becomes 1, 1, 0, 0, 1, 1, 0. And then this becomes 1, 1, 1, 0, 0, 1, 1. Okay. So when you concatenate dominoes, you get a bigger domino where the strings, the top and bottom strings are concatenated. And let's look at what the top string here is. It starts 1, 1. This starts 1, 1. That's good. You know, they match. But then they mismatch here. 0, 1. So they mismatch. Okay, mismatch. Okay, so the goal is to find a sequence of dominoes, and you can repeat dominoes, you can use as many as you want. So the goal is to find a sequence of dominoes such that when you concatenate them, the top and bottom string match. Okay, find a sequence of dominoes so that the concatenated top and bottom strings match. Simple enough. You could tell this to your 11-year-old brother, and he'll mess around. So tinker! He'll mess around, and maybe he'll figure out that you can do it. Okay, he'll figure out a sequence that works. Or maybe he'll figure out that for these 3 dominoes, it's not possible. Okay, so let me give you an example of a set of dominoes for which it is clearly not possible. So if my dominoes were 0, 1, 1, 0, 0, 0, 1, 1, 0, 0, 1, 0, 1. So if I ask you, can you concatenate dominoes so that they match, you'll immediately say, not possible. Come on, man. What domino will I start with? No matter what domino I start with, the first bit will be a 0, and the first bit here will be a 1. 0, 1, 0, 1. So I can't even get started with matching strings. Okay. So it's a non-trivial puzzle. Sometimes it might be possible, sometimes it might not be possible. But when it's possible, you should be able to find me the sequence. And so that's the computing problem. Imagine I could have given this to you as a homework problem in a programming course like data structures. Okay, so here's the input. I give you a set of dominoes, D1, D2, D3, let's say up to DK. So I have K, maybe 10, who knows, okay? I give you a set of dominoes. And I could specify the input in like an input file, okay? Where each domino is a row, and it's, you know, like the top string, and then some separator, let's say comma, and then the bottom string. So string, comma, string, one domino. New line, string, comma, string, another domino, new line, and so on. Okay? So I can certainly give you the input as a text file, a set of dominoes. Okay? And your program needs to figure out, you know, is it possible to find a sequence with a perfect match, top and bottom string? And if so, tell me what that sequence is. Or your program should say, it's not possible. Now, when we write programs as computer scientists, I'll just mention to you that you don't want things that infinitely loop. Okay, so your program should, you know, once it reads this file, it should do something, stop, and output the correct answer. Okay, so that's the domino puzzle. Okay, looks like a computing problem. Let me tell you the subset sum, matching subset sum puzzle. So I'm just showing you the dizzying array of things to which we can apply discrete math, in case you've forgotten what the hell am I doing. Okay, so matching subset sums. Okay, so let's consider a set of numbers. So I'm going to consider the set of numbers 3, 7, 9, 5, 4, 10, 13, just for the hell of it. So 1, 2, 3, 4, 5, 6, 7 numbers. Okay, nice. Okay, so we have 7 numbers in this matching in this subset. Now I'm allowed to take a group of numbers and form a second subset. So let me take a group of numbers which are going to be 7 and 5. Okay, so there's a group of numbers. And let me take another 7, 5, let me say 7, 5, 10. Okay, and let me take another group of numbers. So I've taken 7, 5, and 10. Let me consider another group of numbers, 9 and 13. Technically, these are called subsets of the original set. That's why subset sums. Okay, matching subset. That's what these are, subsets. Okay, now, why do I say, I'm going to tell you that these subsets match. Okay, and why? Because look, if I compute the sum of this subset, I get 12 plus 10, 22. Compute the sum here, I get 9 plus 13, 22. Okay, look, the sums match. So I'm going to call these matching subsets. Okay, the sum of the numbers in the two subsets match. Okay, so in this example, you know, I played around with it to show you, you know what's going on. Okay, but again, we could easily formulate this as a programming homework in a data structures course, maybe even a CS1 course, which is, you know, I give you as input a text file with a bunch of numbers. Okay, so input is a bunch of numbers. And they need not be small numbers like this. You know, these are sort of, you know, very tiny numbers. You could imagine that the bunch of numbers I give you, every number is a 27-digit number, so it's a huge number. Okay, so you couldn't just look at it and say, oh, that's 3. No, it's a huge 27-digit number. So I give you a bunch of numbers. Each line is a number. Could be a large number, like let's say a 27-digit number. Output should be either yes, there are matching subsets that are different. So yes, there are distinct matching subsets, in which case you can present them. You can say here, subset 1, subset 2, and look, they match. subset 1 and subset 2. Okay, so you can present the two subsets and say, look, here I've presented for you two subsets that kind of proves, that demonstrates that there are distinct matching subsets. But it's also possible that there are no pairs of matching subsets. Okay, so the output should either be yes together with two subsets or no. Not possible. Okay, and you should feel comfortable that you could write a program that takes as input this original set of numbers and tries to answer this question. Okay, so the last two problems I showed you were just to show you that we're not restricting our study of discrete math just to situations in the real world where we build a model and then ask questions. We're also going to consider simple problems like these, which are sort of easy to understand. You don't need a model, it's just a very well defined problem, and we can ask you to write a program to solve these problems.